All right, so note-taking guide 8.2, we're talking about dilations. Now, we just explained to you what a dilation is. It's either making something bigger or making something smaller. So the first image that we're looking at is called the pre-image, and the second image after the dilation is just called the image. So this cute little fat penguin right here, he's the pre-image, and then we reduced him to just be this image. Same thing with the flag over here. The pre-image was the small United States, and then we expanded or enlarged it to be the bigger image. So dilations are either taking a big image and making it small, or taking a small image and making it big. Okay, there's a couple of things we need to know when we're doing dilations about how they work. So a dilation is a transformation that changes the size of a figure, but not its shape. The pre-image and the image are always similar. So do you remember yesterday we talked about similar shapes? We said they had to have the same angle, and they had to have a scale factor that got from one side to the side in the new triangle. So these are always going to be similar shapes, which means they have the same angle measure. Okay, usually when we start with a shape, we call it shape A, and then this right here would be called A prime, which really just means the new shape. Okay, so A would be the original shape, A prime would be the new shape. And it tells you down here that that's what we would call it. The pre-image would be called A, the image would be called A prime. Okay. Then on this little box over here, the last thing that you need to know about it is that it's a scale factor that makes you go from the pre-image to the image. So if I wanted you to take my original image, say it was an X and a Y, and I wanted to make it 3 times bigger, what would I do with the X and the Y? I would multiply the X by 3, and I would multiply the Y by 3. Okay? That will take this cute little triangle right here and make it 3 times bigger. So to kind of notice what we did here, number 2, it says dilate this figure with a scale factor of 1/2. So the original is this one. How can I tell that this is the original one and not the new one? Anybody see those little prime marks on this one? The prime marks tell you it's the new figure, right? So the original one was this one. And they took those ordered pairs and they multiplied them by 1/2. So for instance, if we were to just grab this ordered pair right here for B, that would be -1, -5 would be the original ordered pair. And then if we're going to move it by a scale factor of 1/2, we would times both of those by 1/2. So -1 times 1/2 would be a -1/2. And -5 times 1/2 would be a -5/2. So my new ordered pair, which would be B prime, would be this new ordered pair. So did I do that right? -1/2, -2, 1, 2, and a half. How come that's not in the right spot? Shouldn't it be right there?
It should be.
This picture's off the internet, you guys, so I don't know that I believe this picture exactly. I know the math behind what we're doing is exact right here, so I'm just going to guess that they kind of put that spot in the wrong, unless I read my ordered pair wrong, but I did not, right? -1 for sure. So I really think this one's just graphed in the wrong spot, so that's what I get for grabbing stuff off the internet. Yeah. So, all right, the next kind of problem says, state whether the dilation with the given scale factor would be a reduction or an enlargement. Well, how are we going to make it bigger? We're going to multiply it by a number bigger than 1. If we make it smaller, it would be a number less than 1 that we multiply by. So is the scale factor being K, will that make it bigger or smaller? Bigger. So this one's going to be an enlargement. Okay. How about the scale factor of 1/2? Yeah, it's a reduction. It would make it smaller. How about the scale factor of 0.75? It is. It's smaller than 1, so it would be a reduction. And then the scale factor of 5/2. Yeah. Even though it's a fraction, the fraction's bigger than 1. So it has to be an enlargement. Are you seeing how you can tell with the scale factor whether or not our shape should end up bigger or smaller? Okay. So here's some pictures drawn that ask you to look at the dilation from figure A to B. So A is our starting figure, right? We're starting with A, and our new figure is B. We're going to start looking at figure A and see if it reduced or enlarged from A to B. So figure A is this small one right here. Figure B is the big one. So was it a reduction or an enlargement? It was an enlargement. And then I ask you to find the scale factor. So how are we going to figure out what our scale factor was? Well, we're going to compare the ordered pairs. So this ordered pair in our original one, if I called that A, that would be 2, 2. Does everybody agree that's my first ordered pair on my triangle that we started out with? And then B, which is my new shape, that same corner for the ordered pair became 4, 4. What did I multiply both my x's and both of my y's by in order to get from the first shape to the second shape? 2. So guess what my scale factor is? My scale factor is 2. Now we call scale factor with the letter K. I'm not sure why we call it K, but that's the letter that we use to represent scale factor. So you could put K equals 2. All right, are there questions on how we did that? And I just want to remind you from up here where it showed you that you could write your scale factor like this. I could really say what I did was I went from my x comma y's and I went to 2x comma 2y, right? This would be another way to write my scale factor, what I did with my ordered pairs to get to my new ordered pairs. You guys following me on that? All right, so on number 2, figure A was the starting figure. Figure B is the new figure. So from A to B, was it a reduction or an enlargement? Reduction. And then I need to find my scale factor. So let's compare our ordered pairs. So the first one in A starts at the ordered pair 4, 2. And you could pick any of your ordered pairs. I just am going to pick that one. It's just the one that I chose. You could choose any of them as long as you compare the same corner to the same corner on your shape. So if this is 4, 2 starting out with, and then B becomes 2, 1, what did I multiply by to get from 4 to 2 and from 2 to 1? All right, try it. If you do 4 times -1, you'd get -4. So is it -1? No. Nope. That was a good guess, though. Try another number.
So, remember, since we're reducing, we have to times it by something less than 1.
Yeah, for sure. And what did you say, Lorena? 1/2. If you take 4 and times it by 1/2, you get 2. If you take 2 and times it by 1/2, you get 1. So your scale factor is 1. And again, you could write that like this also. It would be take 1/2 times your x value, take 1/2 times your y value. Okay? I don't care if you write your scale factor this way or that way. There will be times they ask you to write it this way. And the reason there'll be times that they ask you to do it this way is because sometimes when we're dilating, we can dilate the x values by one number and the y values by a different number. It's okay to do that on a dilation. Does that make sense to everybody? All right, flip it over and let's keep going then. So the next one says point A is a vertex on a polygon, so any shape. And it says point R is the image after a dilation. So this is my beginning, this is my new. find the scale factor of the dilation. So how did I go from my x values and my y values to my new x values and my new y values? So how did I get from 5 to 15? What did I multiply by? 3 times my x's. And how did I get from 7 to 21? 3. So 3 times my y's. So in this case, my scale factor was 3 on both of them. So I could write it as k equals 3. Okay. What about the next one? Let's take a look at our x's and our y's and see what our scale factors were. What did we multiply 10 by to get to 2?
Or what did we divide by?
Yeah, if you think about divide, you can change it to a multiply problem. What did you divide by? 5. So it would be multiplying by 1 over 5. Okay. Did we do the same scale factor to get from 50 to 10? Yeah. So if you can't figure out how to figure out the 1/5, does anybody know how you can do it? Take the new number and divide it by the original number. So on your calculator, you could do 2 divided by 10 and it will give you 1/5, or 10 divided by 50 and it will also give you 1/5. So again, my scale factor on my x's and my y's are the same number, so I could write it as my scale factor is 1/5. Okay. Now again, I don't think today that we're going to have anything different than the same number on both, but I want to keep writing it this way because I want you to be aware that you need to check both your x's and your y's to find the scale factors, okay? All right, last one here, finding the scale factor again. So I want to see the change that I did from my x's and the change that I did for my y's. So how did I get from 3 to 1/3? And if you don't remember, take the 1/3 and divide it by 3. It's 9.
Wouldn't you just be able to do 27 divided by 3 then and find that out and just copy out and do
You could, totally, yep. So it was 9 times our x's, and then Jordan says it was also
27 divided by 3 is 9.
27 divided by 9 is 3. So is my scale factor 9 or is my scale factor...
I did 27 divided by 3 and got 9.
Okay, so 27
So
divided...
what we need to do is we need to go 3 divided by 27 to get the scale factor.
Right.
And you end up with 0.11.
Which is 1
Over 9.
over 9. So I'm asking, is my scale factor 9 or is my scale factor 1/9? Try it on your calculator. How do I get from 3 to 1/3? If I do 3 times 9, I get 27. If I do 3 times 1 over 9, then I get 1/3. So my scale factor is 1/9, not 9. Are you following me on that? Because you go from here to here by dividing by 9 or timesing by 1/9. And just like I said for you guys to do on your calculator, if you do the new one, the 1/3, and you divide it by the original one, you get the 1/9 in the first place, and you don't have to think about it. Take the new shape divided by the original shape to get your scale factor. Okay? Then you're not confused if it's 9 or 1/9. Okay? All right, the next one, it says a line segment has the given points. Use the scale factor to write the ordered pairs after the dilation. So these are my 2 ordered pairs, and my dilation or scale factor is 3. So what's my new ordered pair for A? What's my A prime? 2 times 3, which would be 6. And then 6 times 3, which would be 18. So A prime is 6 and 18. B prime would be timesing my B by its scale factor, which is 3. So 4 times 3 is,
12,
and then 9 times 3 is 27. Okay, the next one, same thing, but my scale factor is 1/2. So my new A would be A prime. So I'm going to do -4 times 1/2. Good. -4 times 1/2 again, which is -2 again. Then I'm going to do my B prime, which would be my B times by my scale factor. So 6 times 1/2 would be 3. And 1 times 1/2 would be 1/2. So my new line segment would be from these ordered pairs with the scale factor of 1/2 from my original. Okay, 2 more problems and we're done. We're going to dilate this figure given the scale factor of 1/2. So if my original A value is -3, 1, what's my A prime going to be if my scale factor is 1/2? So it would be a -3 times 1/2.
did you get decimals?
You totally can.
Did you get 1.5?
-1.5, okay? And what's 1 times 1/2? 1/2 or 0.5, right? Either way you want to do it. So my A prime is going to be -1.5 and 1/2. So -1.5 and 1/2 right here maybe for my A prime. Okay, let's find our B so that we can find our B prime. Our B is 1, 3. So B prime then will be 1 times 1/2, which is just 1/2. You could do 0.5 if you wanted to. And then 3 times 1/2 would be 1.5. So you go over 1/2 and you go up 1.5. Does that seem right? Over 1/2, up 1.5. All right, my C value is 2 and -4. So my C prime value is what I'm looking for next. I'm going to times 2 by 1/2, which is 1. And -4 times 1/2, which is -2. So I'm over 1 and I'm down 2. And this is my new triangle. Questions on how I did that? All right, last one, then doing the same thing. This time my scale factor is 2. So I'm going to find my ordered pairs and I'm going to multiply them by 2. Let's start with M. M's ordered pair is -8, 2. So what is M prime going to be?
-16.
And 4, right? That's going to be clear off my graph, so let's go and see if we can find the other ones. J's going to be -6, 5 for its original, if I looked at that right, -6, 5. So what's J prime going to be?
-12 and 10.
-12 and 10. Let's do K next. K is -3, 5. So K prime's going to be -6, 10. And then I'd have to do L. L is -1, 2. So L prime is -2, 4. So then I just have to graph these primes to get my answer. We're going to be off this graph here, not very good graph paper for this example, right? So we're -16, 4. We're just going to make our best guess, K. 10, 16, maybe clear over here. And I didn't go probably good enough. -12, 10. -6, 10, and -2, 4. And then your shapes go through those ordered pairs. And if I would have done a better job graphing those ordered pairs on some graph paper, it would look better. Okay, that is how we do a dilation.